Alrighty, so for our lab, we chose a kinetic energy lab. The purpose of this lab was to look at the relationships and study the relationships between the different variables within the kinetic energy equation. Now to start the lab, we want to set the maximum energy to 20,000. This is so that it is not the maximum energy that is causing the fire extinguisher to stop. Then we want to set our extinguisher's force to 200 newtons. This will have an effect on work, which will in turn have an effect on the energy, and so we need to keep it at that set value. Then we also want to set our speed to 10 meters per second, and we're gonna keep it at 10 meters per second. And our mass is going to change. We are going to change the value of our mass throughout this lab. Now, we had previously done the lab, and due to technical difficulties, it did not save properly, and so I'm just going to be doing this as a demonstration of what we did. That is why our numbers in our table and in our lab report are different than the ones that I am showing you now. And so once you have everything set up, we just press activate, and it'll calculate the energy gained. Now each time you press the activate button, you get a different value for energy gained. And so at the end of the experiment, so we did 5 trials for each, since we realized that we were getting a different value for each time. We did 5 trials for 5 different masses. So we started at 50 kilograms, we did 5 trials, then we moved it to 55 kilograms, and we did 5 trials. So we press activate, we wrote down the energy gained, activate, again wrote down the energy gained. We did 5 trials for that one. Same thing with 70, 85, and 90. Now I'm just going to do, I did 55, I'm going to do 70, just so you see that our values in our table are accurate, and so you know that we really did have to retake the video because of due to technical difficulties. 5, we did 85, and again we did 5 trials for each mass, and took the average of the total of the energy gained. 90. We then used our values to study and look at the relationship between the velocity and kinetic energy and the velocity, and also kinetic energy and the mass of the object. And yeah.
Okay, so right now we're going to be looking at the information that we got from our lab. Okay, so our lab was about how certain factors affect kinetic energy, like we looked at speed and mass. So the first part was energy versus speed. We had to pick a mass for our astronaut, and that number had to stay fixed. So we picked 50 kilograms. You can obviously pick whatever you want. It doesn't really affect what you get. We also kept the maximum energy at the maximum number that it would go, which was 20,000 joules, and that was because so that the energy is not the thing that causes the extinguisher to turn off on its own, and we don't worry about this value. That's why we kept it at the maximum, and then we also kept the force of the extinguisher at maximum because it's not relevant. So now we look at our table, speed versus energy. We kept our speed at increasing by 2 each time. So it was like a constant variable kind of. And then we also did 5 different trials to calculate the maximum energy gained. And this was because it was not consistent. So we took 5 various trials to give us the most accurate number, which is what we see here. And then we know the formula for kinetic energy is EK equals half mv squared. And it's because the speed is squared when the kinetic energy, let's say, is doubled, the speed of the object will be quadrupled. So the second part of the lab was looking at energy versus mass. Similarly to the first part where we kept mass consistent when we were looking at speed, we're going to keep speed consistent on this part when we're looking for mass. We had the opportunity to choose between 5 meters per second and 10 meters per second. We just chose 10 meters per second. We also kept the maximum energy and the force of the extinguisher the same amount as the first part of the question, first part of like the lab. So this is all of our information that we collected, speed versus mass. Since the mass wasn't going consistently up by a certain number, we just picked randomly. Again, we did 5 different trials and then got our most accurate answer, calculating the average. And then mass and kinetic energy are directly proportional, meaning as one of them increases, the other increases as well. So let's say if the kinetic energy doubles, the mass of the object doubles as well. Now we're going to be looking at the graphs that we found. This one. Okay. So this was the effects of speed on kinetic energy. We have speed as our x and then kinetic as our y. This is how our graph looks. As we can see, it's increasing. And then this is the effect of mass on kinetic energy. Mass labeled here, and then kinetic energy here, and then our graph, as you can see, increases as well. So those were our graphs and the information collected from our lab.